In this video, we'll be going over differentiation. This is not like differentiation by first principles, but this is an easier form of differentiation. It follows the format. So if we have our function f of x, we have f of x is equal to x to the power of n, then f prime of x. So if we differentiate our function, so f prime of x is equal to n times x to the n minus 1. So what we do here is we move our power of x into the coefficient of x, so multiply it with the coefficient, and then we subtract 1 from our power. So as a nice easy example if we have f of x is equal to x to the 7 to the power of 7, then f prime of x is equal to 7x, because 7 is the power, and then 7 minus 1, which gives 6. So this is equal to 7x to the power of 6. Now we can approach our questions. So for A, we can just do this as y is equal to x to the power of 4 plus x to the power of minus 1. Now, the notation for when we differentiate with y is dy over dx. So this is just the change in y over the change in x. So the rate of change in y. So we have x to the power of 4. So we bring our 4 down as our coefficient. So we have 4. And then we have x to the power of, so 4 minus 1, which is 3. Now, for differentiation like this, we have to differentiate each term individually, where each term is a coefficient, x, and then the power of x. So here, for the second value, we have the power of x is minus 1. So we just do minus x, and then minus 1 is equal to minus 2. So we have 4x cubed minus x to the power of minus 2. For B, we can write it as y is equal to 2x to the 5 plus 3x to the minus 2. So dy by dx is equal to, so our coefficient here is 2. So we multiply this by our power, which is 5. So we get 10x, and then 5 minus 1 is 4. So we get 10x to the power of 4 plus, so our power for x in our second term is minus 2, and we multiply it by 3. So you get minus 6x, and then minus 2 minus 1 is equal to minus 3. So we're left with the differentiated form of 2x to the power of 5 plus 3x to the power of minus 2 as 10x to the power of 4 minus 6x to the power of minus 3. Now let's look at C. For C, we have 6x to the power of 3 over 2. So y is equal to 6x to the power of 3 over 2 plus 2x to the power of minus 1 over 2 plus 4. Now, when we differentiate here, we have dy by dx is equal to, so the power of x here is 3 over 2. We multiply that by 6, and so that is in front of x, and then we have x to the power of, so 3 over 2 minus 1, plus, now we have 2 as our coefficient of x, and we multiply it by minus 1 over 2, as this is our power of x. Then we have x to the power of minus a half minus 1. And then 4 can be written as 4 times x to the 0. And so, because x, any number raised to the power of 0 is 1, and 4 times 1 is just 4. So here, if we bring our power of 0 down and multiply it with our 4, any number multiplied by 0 is 0, so we don't have to worry about our last term. Now we can start to simplify our fractions here. So 6 times 3 over 2, we can cancel out our 6 and a 2, so we get 3 times 3. So our coefficient of x here is 9. We have 9x, and then 3 over 2 minus 1 is equal to 1 over 2. So we get 9x to the power of 1 over 2 plus, so 2 times minus a half is equal to minus 1. So we have minus x, and minus a half minus 1 is equal to minus 3 over 2. So we're left with dy by dx equal to 9x to the power of 1 over 2 minus x to the power of minus 3 over 2. And this is the simple differentiation, not differentiation by first principles. As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.